All right, today we're learning section 4.1, prime factorization. All right, the first thing you need to know are the terms. Okay, what's a prime number? A prime number is a number whose only factors are 1 and the number itself. A composite number has other factors other than 1 and the number itself. Okay, so if it even has one other factor, it's composite. An example of a prime number could be 3, 5, 7, 11, 13, 17. That's just a few. Okay, so all of these numbers have one thing in common. Their only factors are 1 and the number itself. There are no other numbers that can evenly go into these numbers. A composite number has other factors other than 1 and the number itself, like the number 8, 10, and 15. All of these numbers, okay, what's another factor for 8 other than 1 and 8? What's another factor?
2.
2. What about 4? Right? What about 10? What's another factor? What's another factor? 5 or 2. What about 15? 5 or 3. Okay, so these numbers have other factors other than 1 and the number itself. That's the difference between a prime and composite number. You don't have to write down all of those examples of numbers, just as long as you get the main concept. All right, so in example 1, we're listing the factors of a number. Okay, so let's take the number 36. The number 36. All right, and we always want to start with 1 and the number itself. So we have 1 times 36. Okay, and then we're just going to kind of go up in intervals of 1. So we're going to ask ourselves, okay, 1 times 36 is 36. 2 times, can 2 go into 36?
Yes.
Yes. How many times?
13.
18.
18.
Okay, so 2 times 18. What about 3?
Yes.
3 times
12.
12. What about 4?
4 times 8.
4 times 9.
Oops.
What about 5?
No.
What about 6?
6 times 6.
6 times 6. What about 7?
No.
What about 8?
No.
What about 9?
Wait, no. 9
Okay, 9 times 4, and yes, 9 has already been listed, 9 times 4, except it was 4 times 9. So as soon as it starts repeating itself, you know that you've listed all the factors. So you go through and notice how we just kind of increased that first number. We just went up 1 through 10 or whatever it was, okay? So that's the easiest way to make sure that you don't miss any numbers. Just ask yourself, okay, 1, can 2 go? Can 3 go? Can 4 go into it? And just work your way up. All right, so now that we have listed all of the numbers that multiply together equal 36, now we're going to list our factors least to greatest. So we start with 1, 2, 3, 4, 6, 9, 12, and 36. And this would be what you would box in. Okay? Oh, I'm sorry. I missed 18. Sorry about that. 18 and 36. All right, so this is your work that you would show on your homework, and this is your answer that you would box in on your homework. And we'll go over this at the end of the lesson today as well when we're going over homework. All right, so moving on to example 2. Okay, now we're just looking to see, are the numbers prime or are they composite? So if I had the numbers 56 and 11. Okay, and I'm asking myself, okay, is 56 prime or is it composite? I need to try to think of some other number other than 1 or 56 that go into 56. 8. Does any other number go into 56? Yes. What? 7, 8, 2. Okay, so I would say this is composite. 56 is composite. And on your homework tonight, you're going to need to explain your reasoning. So in explanation here, I would say it is composite because 8 times 7 equals 56. So I'm showing that some other number other than 1 or 56 can be multiplied together to equal 56. It has other factors, basically. All right? So what about 11? Does 11 have any other factors?
No.
Besides 1 and 11? No, it doesn't. So I would say that 11 is prime because only 1 and 11 are factors. Now, I don't mind if you use abbreviations and numbers in there, but don't say R for A-R-E. All right, don't write texting lingo on here, okay? I don't mind some abbreviations, but don't say prime because only 1 and 11, the letter R, factors. Don't do that, okay? All right, so, yeah, I've got kids doing texting like, are you, the are you, and I'm like, oh my goodness. Yeah, so don't do that. All right, any questions on example 2? Okay, identifying prime and composite numbers. Is it prime or is it composite? Now in example 3, we're using a factor tree now to do the prime factorization. So let's start out with the number 54. 54. I need 2 numbers that can be multiplied together to equal 54. What could it be? 9 times 6. Or let's start off with 2 times 27. Okay? Now, the reason you might want to avoid doing a factor tree that already starts with a prime number, you see how this one already starts with a prime number, is because this side, the side of 27, is going to be really heavy. All the numbers are going to be over there, and then you just bring the 2 down. Okay? So you want to even it out if possible. So I know that some of you said 6 times 9. That's exactly what I was thinking. All right, so we would want to start with 6 times 9 or 9 times 6, either one. And then you ask yourself, okay, 2 numbers multiplied together to equal 6. What would that be? 2 numbers multiplied together to equal 6. 3 times 2 or 2 times 3. Okay, what about 9? 3 times 3. And you know that you're done when all the numbers on the bottom row are prime numbers. Are they all prime?
Yeah.
Yes, they are. Okay, but that's not your final answer. Anytime you have repeated factors in your prime factorization, do you see a number that repeats itself? 3. You're going to write it as a power. So our simplified answer would be
2 times 3 to the third power.
2 times 3 to the third power. And that's your answer. Okay? Okay, now the last concept that we're going to cover, we just learned factor trees. Now we're going to learn another way to do prime factorization. How many of you have ever done the upside down division? Anybody ever done upside down division? Now, I'm going to make this very clear, okay? So listen up, okay? Now, anytime I ask you to do the prime factorization of a number, you can either use a factor tree or you can do the upside down division. It's your choice. So if you prefer factor trees, go for it. If you prefer, all right, so either one, whatever you prefer. All right, so let's do upside down division for the number 48. Okay? Now, the key here, the most important part about upside down division is that you must divide by a prime number. It has to be prime, okay? So, can anybody think of a prime number that could go into 48? Zach? 2. Very good. And 2 goes into 48 how many times? Anybody know? What is it? 24. Very good. All right. So now I ask myself again, what's a prime number that can go into 24? 2 again. Very good. And that goes in 12 times. What's a prime number that can go into 12? 2. 6 times. All right. What's a prime number that can go into 6? 2. How many times?
3.
And as soon as you have a prime number down here in this bottom number, you're done. Okay, so you don't have to say 3 goes into 3 one time. You don't have to do that. Now you have the prime factorization of the number. Okay, but you're not done, because do you have repeated factors?
Yes.
Yes, you do. So what would be your simplified answer here for the prime factorization, Hazen?
2 to the 4th power times 3.
Perfect. 2 to the 4th power times 3. Like I said, either way is fine. Okay, so if you want to do factor trees, you would get the exact same answer if you did it right. If you want to do upside down division, which I kind of prefer that way, but it's fine either way, then you would still end up with the same answer. The key here is make sure that what you're dividing by is actually a prime number. That's important. If it's not a prime number, then you're going to get the answer wrong. All right? Okay, and if you understand that, that's everything you need to know for 4.1.